Hi, this is Ajit. Welcome to my step-by-step data science YouTube channel. So today we will discuss about writing basic NumPy required for machine learning equation. Then we will discuss about writing hypothesis of univariate linear regression. Then we will write cost function, and then finally we will write equation for gradient descent. So these are the topics that we will cover in this tutorial. So let's start with basic NumPy, creating one-dimensional array. So this is my NumPy library. So I think everybody knows how to create one-dimensional array. It's quite easy. Let's create it first. 1, 2, 3, and another p equals np dot array 2, 3, 4. Let's begin bracket. So I have created two arrays. So if we need to look at dimension, we can look ending. We have one dimension array. You can see the same. We have 3 rows in the array. So if we need to do multiplication, A into B. So this is element-wise multiplication. We need to be very careful regarding element-wise and matrix-wise multiplication. So in element-wise multiplication, we simply multiply each column. So 2 into 1, 3 into 2, 4 into 3. However, for matrix multiplication, suppose A at the rate B, we got 20. This is the matrix multiplication. So how this is done is, suppose, suppose our A is 1, 2, 3 and B is 2, 3, 4. So A at the rate B is simply multiplication of this times this. So plus 2 times 3 plus 3 times 4. This is equals to 2 plus 6 plus 12. This is equals to 20. So this is how we do matrix multiplication. So A at the rate B means we are doing matrix multiplication. We can even denote it by np dot A comma B. So these both are same, A at the rate B and np dot both are same. So let's create a two-dimensional array now. A equals np dot array. So to memorize how to write two-dimensional array, so we know that it needs to be in 2 rows. So we need to have 2 square brackets ready for two-dimensional array. So let's say if it is 1 comma 2 comma 3 comma 3 comma 4 comma 5, and it's to be equals np dot 3 comma 4 9 comma 2 comma 1, say. So if we do A times B, this will again do a matrix element multiplication, element wise multiplication. So asterisk stands for element multiplication. 2 times 1, 3 times 2, 4 times 3. Okay, so if we have another column, suppose let's say K equals np dot array suppose it's 1 comma 2 comma 2. So let's say if we store our result, let's say this is my key and this is my A. If we need to do a multiplication for K times A, it again does element wise multiplication. If we do K at the rate A, this will not be valid because we need to transpose first T. we need to transpose to it k dot t. So it will give 11 comma 21. How this works is, suppose let's say our a is 1 comma 2 comma 3 two-dimensional array 3 comma 4 comma 5, and our k is 1 comma 2 comma 3. So why do we need to do transpose is because if we need to follow for matrix multiplication, we need to follow this rule. So whenever we multiply, we follow this convention. What does this mean is, suppose if a is my 1 2 3 3 4 5 and times 1 2 3, suppose. So we need to follow this and this convention. So this, in order to follow this convention, like we need to transpose our matrix. Now if we transpose our matrix, we can simply multiply this by this. So this becomes 1 times 1 plus 2 times 2 plus 3 times 3 comma 3 times 1 plus 4 times 2 plus 5 times 3. So 1 plus 4 plus 9, which is equals to 19. 9 10 plus 1 11 comma 3 plus 1 is 8 21. So this is how we get matrix multiplication. So we need to make sure that for if we do a matrix multiplication, we follow this convention while we doing a multiplication, which means like if my row is 1 2 3, then my column should be 1 2 3 in order to do a multiplication. Should follow this convention. Hope this makes sense. So this is how we do matrix multiplication for a two-dimensional array. So if we need to create a vertical array, it means like here we created horizontal array. So in order to create a vertical array, what we can do is, suppose np dot array bracket 1 2. We need to make sure it's in square bracket. So this is how we create a vertical array. Now if we need to repeat some numbers, suppose if we need to repeat 1 to 2 0.1 times, so how can we do that is we can use np dot range bracket suppose 1 to 0.1 times. So this gives me the repetition. One thing to note is that from 1 to 2, the last one is not included, so the last one 2 is excluded. So if we need a number, suppose from 1 to 7, if we need an even number, from 1 to 7 if we need an even number, if we need an auto increment number, suppose let's say 1. So this will give me 1 2 3 4 5 6, but it will not include 7. So 7 is excluded. So in similar way, if we need to repeat something for 20 times or 100 times, we can even use np.line space. Suppose if we need to repeat 1 to 2 25 times, it is repeated 25 times, we get the number between 1 to 2. and which is repeated 25 times. So this makes sense. Here we include both 1 and 2. So moving to ones in array, so it's quite easy. Say ones, double bracket, we need to make sure we keep a double bracket, 2 comma 3. So this is how we create ones. So in order to create zeros and zeros bracket open bracket 3 comma 3, this is how we create zeros. So if we need to create a random number, so np dot random dot rand 2 comma 3. So this gives me a random number between 2 to 3. If we need to create a random number for a normal distribution is like we have a standard normal value where we do like z score, we calculate z score. So if we need to generate a random number for a normal distribution, so let's say if we go input dot leave dot 5 dot sp. So if my data is, suppose my mean is 5 plus np dot square 3 times np dot random dot rand n gives us the normal distribution. Suppose if we keep 10,000, so it's like using here a, which gives me a random normal distribution. So if we need to plot, suppose histogram, suppose, so here we can see the histogram of a normal distribution where my mean is 5 and my standard deviation is the square root of 3. So if we give a beans, suppose if we give beans equals 50, and this looks quite good, where my mean is 5. I have taken my mean, and my standard deviation is this square root of. So now let's move to slicing. How do we slice our numpy array? So these things are all necessary to write machine learning equations. Therefore, I'm explaining you these concepts. Suppose 5, 6, 7. So if we take phi of 1 comma 1, this gives me 6 comma 7. How this works is, suppose we have 1 2 3 5 6 7. So what does b1 1 does is, so this is my 0 index and this is my 1 index. So this is 0 1 2 0 1 2. So what does is, so this one means this and this means all. So one row all, so which means 5 6 6 7, but my starting position is 1, which means 6, and this means all 6 comma 7. Likewise, if we need to add new array in NumPy, let's say. So suppose in here 1 comma 0 all. If I add new array, let it see. So on the so here we have changed our array from like this one is for this position starting from 0. So this is my row and this is my column. So this is the starting position and this is the what I have converted it to 4 5 6. Hope this makes sense. So how we append our array? Suppose if p equals np dot append, suppose if you need to append 1 2 3, this is how we append our array. So appending array, suppose if we need to append it vertically, suppose if by array is 2 3 4 6 7 8, suppose let's say we have another array with this say 8 9 0 1. If we need to append this to array vertically, what we do is p equals np dot v stack v comma g. If you look at this, then this new array is vertically stacked in my new array. So similarly, how we do horizontally, how we add our array is, suppose if we have 3 4, suppose we have another array 0 comma 1. Suppose if we do the np dot add stack b comma g, opened our array. If we need to if we need to flatten our array, then we can say v dot b shape -1. So let's say we did vertical stacking. Now if we do it horizontally, it flattens out into one single column when we do -1. Likewise, if we need to take our row wise, we need to take some based on row wise. So we do this array bracket. So I'm discussing this because this is all we need while writing our machine learning equations. So this is extremely useful. np dot sum a comma x is equals comma. So it does row wise addition. What does this mean is like if we have a equals 1 2 3 3 4 5, then it multiplies, it adds, sorry, this this is equals 4 comma 6 comma 8. This is when x is equals 0. Likewise, x is equals 1. This does column wise addition, which means this and this, which means 1 plus 2 plus 3, which is equals to 6. 3 plus 4 plus 5, which is equals to 12. Now we have covered a bit of NumPy, basics of NumPy. So let's import all this library to start writing our equations for univariate linear regression. So what does univariate means is, univariate means we have only one feature, which is called univariate. So the equation for univariate is, the hypothesis equation for univariate is as of theta so our equation is as theta of x equals theta naught plus theta 1 x. Why do we need suffix and x is because this hypothesis is dependent on theta and x. That's why we denote here suffix theta and we write here x. Okay, so this is my file that I have taken from Andrew Ng Coursera data. So this is the data that we see in Coursera file. If we do Andrew Ng Coursera course, we will find this data there. So I'm using that. So if we need to look at header, so this is my head, this is my one feature, and this is my output. So let's say this column header. So my x variable is x variable is this and y is this. So I only have one feature and my one output. That's why it's called univariate, because we have only one feature, one input and one output. That's why it's called univariate. So let's say for x we have included one feature and our output y is another feature. So here we will write our hypothesis function. So what does this hypothesis means is, suppose this can also be written as of x theta naught x naught plus theta 1 x1. So what we are going to do is, we are going to do a matrix. What does matrix means? Like, we are going to derive our equation where our theta is stored in matrix, like theta naught theta 1. Okay, and our x naught is, because we have equation of theta naught plus theta x, theta 1 times x, theta 1 will be by default 1. So our theta x1 will be our one new feature, which is 6.1101 5.2277. So this is what will be our x1. Okay, so initially we will set our theta 0 and theta 1 as this. We will set as 0 0. Okay, and then for populating theta naught by default 1, we will again create another matrix for theta 0, which will have all 1 1 1 values. Okay, so does that make sense? I think. Okay, so let's create, let's first create our x naught, which is by default 1 1 1 1 up to up to the length of our data, up to length of our data. So why we need to create this as 1 is because we have our hypothesis function, sorry, theta naught plus theta 1 x. This x naught here is 1. Okay, I think that makes sense. So let's create my x naught, which is equals to np dot 1, and this will be my length of total records. So x naught will be my 1 matrix. X naught, if you see, we have all 1 1 1 created. Why we did that? This is because we have our equation theta naught x naught. X naught is 1. Okay, that makes sense. And again, I said that initially we will define our theta as, let's say, np dot 0 comma. This is just for testing purpose. I will explain you more in detail. So let's say my theta is 0 0. Why we did 0 0 is because we have two theta value. One is for x naught and one is for theta naught and one is for theta 1. Okay, so what we did right now is we created x naught, which is our all 1 1 1 so on up to the length of our data, and we defined our theta naught and theta 1 as 0 comma 0. We know our hypothesis equation is theta naught plus theta 1 x. This x is our mean feature. This is our main feature. Okay, so what we need to do now is we need to combine both x naught and x1 in one array. So here will be 1 1 1 and another x1 will be suppose this will be our first feature, which is 6.11 5.52, and then we have, why we are doing this is because we need to do a matrix multiplication. That's why we need to combine both feature. So let's combine that first. So this is my one matrix. Okay, so till now what we did is our x equals 1 1 1 1 and so on up to our length of data. Okay, and another is 6.11 5.22 so on up to length of data. Okay, so we have our 1 so on 6.1.5 so on. This is our one matrix, and another matrix is, this is again our x naught, this is again x1. Another is our theta, which is 0 comma 0. Okay, so what we are going to do is, now we are going to do a matrix multiplication. That means 0 comma 0 1 1 1 1 6.1 2.5. This is our matrix multiplication. This by this, again this by this. I again said we need to follow this convention. This by this by this. So what does this does is, this is my theta naught, this is my theta 1. So what does this? Theta naught times x naught plus theta 1 times x1. This is again, this is again my x naught, this is again my x1. So why we did matrix multiplication is because we need to generate hypothesis that does a multiplication, which means our hypothesis is theta naught plus theta 1 x1, which is similar to theta naught x naught plus theta 1 x1, where this is 1. So in order to have this multiplication, we need to do matrix multiplication. Hope that makes sense. So I have my one array and one random theta values, that is 0, and another is my array. Now if we do, now let's write hypothesis. Okay, so at theta equals np dot, because this does matrix multiplication, theta comma x return h of theta. Looks like that. So h of theta equals hypothesis x comma theta. Okay, now let's say our theta is, let's say we have used another 2x2 dimension, two rows, where suppose 1 comma 2, we have theta 0 is 1, theta 1 is 2. Okay, so my h of theta will be hypothesis x comma theta. So if you look at my h of theta, this is all the matrix multiplication. That is 1 times 6.11 plus 2 times. It is simply a matrix multiplication. So this is my h of theta. So this is how we do h of theta. So we can do transpose of theta even if we need, because but all it depends on how we write formulas. So one thing we need to make sure is, whenever we do matrix multiplication, suppose if we need to multiply x times x, this is equivalent to x transpose x. So this is how we do matrix multiplication. So if we are multiplying, if my row is theta 0, theta 1, theta 2, and so on, so my column of multiplications would be x1, x2, x3 up to xn. So this is my convention on how we do matrix multiplication. That's why we take theta transpose x. We see that what we write in our hypothesis function. So it completely depends on you how you derive the logic. You can take transpose, or even without taking transpose, even if you can write real equation. Thank you. Hope that makes sense. I think so. Let's write cost function. So what is cost function is, it's the error, how much error we will get when we implement a linear regression module. So hypothesis is what would be our initial hypothesis, how we will get the linear line, univariate linear line, and cost function is the error, how much error we will get in the module. So this is my equation. So right now we have calculated hypothesis, which is h of theta. So let's what does this equation means is, j of theta naught comma theta 1 equals 1 by 2 m I of 1 to n s theta x of I minus y of I whole square. Whole square is done to eliminate the negative and positive if values, so we do whole square. This is also called mean squared error. The I is our row and m is our total length of data. I is individual column, individual row, and yeah, this is what we do, the multiplication, matrix multiplication. So this is my cost function, the error that we, how much error that we get in a module. This is called a cost function equation or mean square error. It's the same. So let's write it down, this equation. So complete cos x y theta. So initially we will find, we already know our h of theta, so this thing we already know. So let's write this first. H of theta equals my this one. This is right now we have included theta, we have randomly included theta, but later we will explain how we will calculate theta even while implementing gradient descent. So the second thing is, now we need to do j of theta, which means this minus hypothesis minus y whole square. J of theta will be my h of theta minus y. Y is, this is my y, this is my y that we predicted. We will be drawing our target variable, so we need to do square of this. That's how we do square. Again, this is what we did. So now what happened is, our j of theta naught and theta 1. Why we do theta naught and theta 1 is because right now we are our hypothesis is theta naught plus theta 1x. That's why we are taking two variable, theta naught and theta 1. That is equals to 1 by 2m. Sigma I equals 1 to m. M is our total rows, total record, and this is theta naught of x of I minus y of I whole square. Okay, so right now what we did is we wrote logic for this one. Okay, so let's say if we have hypothesis as theta of x 2.5, suppose 3.2, 3.7, suppose, okay, and my y is outward variable like 18, 14, 15. Okay, so now we need to subtract this and this, so this minus this, then we need to take this is what this is, our sum. So right now we subtracted this, then we will take sum, and then we will divide by m, which is our total length of data. Okay, so a of theta sum is sum, okay, divided by 2 times m, 2 times m. Okay, so I think we have not calculated m, so my m is length of x or y, can be anything, so total length. We will return j of theta. Okay, so let's say my theta now is -1 comma 2. Okay, so j of theta will be 54.24. So this is my cost function. This is the error that we get when we apply this module. Hope that makes sense. Now what is gradient descent? Gradient descent is finding the y. That's what gradient descent is. So how we need to implement this equation, and in this equation we will see, if we implement this equation, we will get optimal value of theta where we have minimum error. So what does this equation means is, write it down. Theta of j equals theta of j minus alpha delta theta of j of theta naught comma theta 1. Okay, so this alpha is our learning rate. What is learning rate is the rate that it's the step that the model takes to run. So it should be, it ranges from 0, we start from 0.1. So it's the step, how much step should we take while running a module. So it's the minimum step that we take to run a module. That's our learning rate. So we know j of the theta is j of theta naught comma theta 1. We already know this, which is 1 by 2m sigma equals 1 to m h of theta of I minus y of I whole square. Now if we take derivative of with respect to this, then what we get is 1 by 2m sigma I equals 1 to m h of theta of I minus of theta of I into xi. So how did we get this is, we simply did our derivation based on theta 1. So we know that d of x to the power n by d of theta is equal to mx to the power n minus 1. Then so let me do it from power n minus 1. So we know theta of j is theta of j minus alpha of divided theta of j, that's theta minus y whole square. So if we do derivative with respect to theta j, this will become 2 times d of h of theta minus y divided by d of h of theta minus y times d of h of theta minus y divided by d of theta. So this is a square, we don't have this right now. So this becomes 2 times h of theta minus y, and if we calculate value of h of theta naught of x, theta 1 of theta naught, so this becomes 0 and this becomes 1, so the things remaining is x. So becomes 2 times h of theta times y times x. So our gradient descent becomes theta of j equals theta of j minus alpha of h theta minus y times x of j. So this is my gradient descent. So this is by choosing theta so that we get minimum error. Now let's implement this. Hope this makes sense. If a gradient, we have value x, y, theta, alpha, dimensions. Okay, so we know m is my length of y. Okay, so let's say right now I have created my empty list error, and my theta is it's 0, and theta 1 is 0. So I will do my iteration. Why we need to do iteration, I will explain that in a minute. Now so first will be my x of theta, okay. So j of theta, this is all that we computed. So compute cost, this is what so the error is stored in j of theta. So let's append that. Why we are appending is we need to check like how much iteration do we get minimum error. That's why we are storing that in array. Okay, so what we are going to do now is we know that now we know that our theta j is theta j minus alpha. Now if we solve our derivative, then it will be h of theta minus y times x naught. You also need to include 1 by n. So let me write it down correctly. So my theta of j will be theta of j minus alpha. This is my learning rate, and it will be h of theta minus y times x, and this whole will be divided by m. Okay, so we need to generate this equation. So let's do so this will be, let's say if we give this delta, so let's say theta j will be theta j minus alpha delta. So in delta we need to subtract this and do multiplication with this and then divide with this. Okay, so my delta will be np dot of theta minus okay, then comma x. So again, if you need to do matrix multiplication, one needs to be transposed. Okay, so I am doing transpose, then divide by m. Okay, then this is multiplied by alpha. Okay, so this is my equation. So so my delta is h of theta minus y. Okay, so this is being again multiplied by x. So this is my matrix multiplication, so we need to do transpose this. Okay, so we need to transpose, then we do divide by m, then we finally multiply it by alpha. Okay, so why we need to do transpose is it because if h of theta minus y, if we generate the output, okay, I will show you that. So my h of y is h minus y is in one-dimensional array. So suppose -4 to suppose let's say so on. Okay, and my x is in two-dimensional array. Okay, my x is not two-dimensional, I mean 2D 6.11. Yeah, it's two-dimensional 5.2.5 7.0. Okay, so we need to inverse this in order to have a matrix multiplication. Okay, so if we inverse this, and my output becomes, if I do x dot t, it becomes 1 6. Okay, 1 5.2, and my hypothesis s minus y is -4 2 3 and so on. So here we can do, so it becomes like this: -4 2 1, suppose 1 6 1 5.2. So it performs matrix multiplication like this. Okay, so this is my h of theta minus y, and this is my x dot t transpose, so which I have written. Then I have divided this by n, then do the multiplication by alpha. Okay, that makes sense. Then finally we need to do theta will be equals to theta minus delta. Okay, so if then I will return my theta and error. Okay, so suppose if my iteration is just to check like in how many iterations we are getting minimum error and optimal theta. So let's say my alpha is 0.1. Okay, so theta comma error is this. So here my normal iteration is, okay, if we take theta, it was 0.01, sorry. So now we have optimal value of theta. So this is my optimal value. Now if we plot our error, where we can say like in near about 500, so my error is continuously decreasing, and around 600 400 to 600 the error looks consistent, so we don't need to iterate over 1500 times. We can even do it till 400 to 600. So this is my optimal value of theta. So if we need to do a prediction, suppose let's say y. So this is my prediction. Now let's plot my predicted value x of 1, because the 0 is completely 1. So y predicts comma, suppose my macro size is in comma color is blue, comma label is 3D pixels. So this is my linear regression line for univariate linear regression. So this ends my equation. So this is how we write gradient descent, cost function, hypothesis, and basic numpy. I have covered all these topics. Hope this video was helpful. Please, if you like this video, please subscribe my channel, and thank you so much for watching this video.